Hi there, this is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 students working on the measurement and geometry unit. It's video number 5, the last video on the geometry section. And in this video, just like in video 4, I'm just going to present you with a few questions that have appeared on previous EQAO examinations and take them up. So remember that every question will involve us using all the skills that we know and we reviewed in the first 3 videos. So no question is going to be necessarily straightforward. All of them involve us thinking to some degree. So let's look at the next question. It says ABCD is a quadrilateral. What is the measure of angle BAD? Ooh, angle bad. So don't forget that this symbol here means angle, and BAD means start your pencil at B, trace to A, and then to D, and you've traced out, in this case, this angle here, which says 4x. So I need to know what that angle is. Now, what do I have? Well, I know I have a quadrilateral, and each of the angles in a quadrilateral are given to me. Of course, they're given to me with x's. But I know that because I have a quadrilateral, that the sum of these angles must be 360. So I can say that x plus 4x plus 3x plus 2x is 360. And again, we know that rule from a previous video. You should have this memorized, that the sum of the interior angles in a polygon is equal to, so in this case, 4 sides. So 4 minus 2 is 2. 2 times 180, and that's how I know it's 360 degrees. So I took all the interior angles and added them up. So what do I have? I have 1x plus 4x plus 3x plus 2x. I have 10 x's. And to solve for x, divide by 10. Now I know that x is 36. But don't think you're done the question. There was nothing that said solve for x. It said, what is the measure of angle BAD? So angle BAD is 4x. So angle BAD is 4x. So therefore it's 4 times 36. So now I can tell you that the measure of that angle is 144 degrees. So a pretty straightforward question, and you'll notice that it's a question that involves not just your knowledge of geometric properties, but also your ability to collect like terms and solve for an unknown. So let's look at the next question. Okay. Paul's grandmother, oh, can you hear me chew gum? Hold on. I'm going to take my gum out just in case you heard that. That would be gross. Paul's grandmother wants to use quilt pieces to make an 8-pointed star like the one shown. So here's a lovely 8-pointed star. Now, her quilt pieces are in the shape of a rhombus with 2 angles of 130 degrees. Is it possible to make an 8-pointed star using copies of her quilt pieces? So in other words, could I take this, copy it, so I have 8 pieces, and then sew it together to form this? I mean, it looks like I should be able to, right? I mean, let's use my fancy technology here and say, like, there's one, right? So there's one of them, and then here would another one be, and I can rotate it to make it look like this one. So it looks pretty good, but obviously there's some math we're going to have to do. So what math should we do? Well, let's look back at the 8-pointed star. We can see that there's 8 of these pieces, and they all meet around the middle. And if they all meet around the middle, then the sum of their little angles here must be 360 degrees. So let's clear that up and look again. And this time I'm going to use a dot. This angle plus this angle plus this plus this plus this plus this plus this plus this must all add to 360 degrees, and that's because all of those together form a perfect circle. So let's make sure that they add to 360 degrees. So if I have a circle and I've cut it into 8 pieces, and that's exactly what this diagram suggests, that I have a circle and I've cut it evenly into 8 wedges. 1, 2, 3, 4, 5, 6, 7, 8. So how many degrees should each of those wedges be? Well, so each angle in the middle, let's say center, must be 360 divided by 8, and 360 divided by 8 is 45 degrees. So again, let me clean my picture up a little bit so you can make sure you understand what I'm saying. Each of these must be 45 degrees. And that sort of makes sense actually, because when I look carefully at the diagram, I definitely appear to have a 90-degree angle here. And I definitely have a straight angle here. And there's 1, 2, 3, 4. So it makes sense. Each of these internal angles must be 45 degrees. So in the rhombus, I must have a 45-degree angle right here. And because it's a parallelogram, that means that this angle here would also be 45 degrees. So is that possible, knowing that Paul's grandmother has already got pieces where there's 130-degree angles? So let's see. So I'm going to ask this question. Is this a valid rhombus? So the rhombus what I know about what I think is a rhombus is that this is 130 and this is 130. That was given to me in the question. And I've just discovered that this has to be 45 and this has to be 45. And can I make a rhombus that looks like this? So let's check. Does 130 plus 45 plus 130 plus 45, does that equal 360 degrees? So make sure you don't write just an equal sign. Make sure you say, I'm wondering if it equals. So let's do the math. 130 plus 45 plus 130 plus 45 is 350 degrees. And 350 does not equal 360 degrees. So we know we have to have a 45-degree angle here, but we're already told that this is 130, so therefore this is not a valid rhombus. And therefore, so no, it's not a valid rhombus, therefore Paul's grandmother, GM, cannot make this shape. Okay, so again, we had to make sure that these pieces here had the right angle to fit perfectly around in a circle. And what we discovered is that that angle would have to be 45 degrees, and the rhombuses that she's cut out would not have a 45-degree angle there. Okay, a great question. Let's look at the next one. Examine the figure below. Okay, what do we see? I see a 5-sided figure, and there is a isosceles triangle in it. It says, what is the measure of angle FEG? So I want to know the measure of this angle right here. So I like to highlight that in red. So how am I going to find that? Well, this is a triangle. And it's not just a triangle, it's an isosceles triangle. An isosceles triangle has a wonderful property that the feet of the equal sides are also equal angles. Now, I don't know if it's formally called the feet, but that's the way I've always thought about it. I think of the two legs being equal length, and therefore these being equal feet. That's just the way my brain works. Now, therefore, if I call this x and I call this x, then I can say that 72 plus x is 180 degrees because that's a triangle. So 72 plus 2x is 180. Subtract 72. 2x is 108. So x must be 54 degrees. So therefore, angle FEG is 54 degrees. So did I have to worry about the whole 5-sided shape? Nope, not at all. Haha, that was pretty nice. Next question. In the diagram below, line segment AB, line segment EB, I can read, line segment EB, so let me highlight line segment EB. Line segment EB bisects angle ABD. So here's angle ABD, and that red line bisects it. And what that means is that it cuts it into two even angles. And you can tell that because this dot and this dot tell me that I have the same angle. So I'm actually going to call it angle X. Whatever it is, let's call it angle X. Now I have to find the measure of angle ABE. So ABE, I've already labeled it X, so that's good. So how are we going to find it? Well, look at the rest of your diagram. I have a triangle here in ABC, and I'm missing one angle in that triangle. Let's say I'm missing this one, Y. So I can find Y by using the triangle sum rule. We know that the sum of the angles in a triangle is 180 degrees. Oops, almost spelled something weird. So therefore we know that 60 plus 70 plus Y must equal 180 degrees. So do the math. 130 plus Y is 180. So Y is 50 degrees. So I found the measure of this green angle here. How does that help me find X? Well, you should notice obviously that there's a straight line right here. And we know that in a straight line, there's 180 degrees total. So this straight line, so I'm going to say straight line, is made up of X plus Y. So X plus Y must be 180 degrees because of the straight line rule. Now I already know that Y is 50 because I found that math already. So therefore 2X plus 50 equals 180, and now I can solve for X. So 2X equals 130, so X equals 65 degrees. And that's what I was looking for, so I can say therefore angle ABE equals 65 degrees. So notice that it's a fairly straightforward question. Just be careful about how you are recording and justifying the math that you're doing. And is that it? Boy, that's it. All right. So there's obviously a lot more geometry questions that I could ask you, but I think that that's enough for now. If you want more, please post in the comments section. I'm happy to do more for you. For now, though, this is the end of the course. Oh dear. So you know everything you know. Hopefully you know everything. And now you're just studying for the EQAO. Well, again, ask anything that you need to ask from any unit, and I'll try to make a video for you. By all means, come to the math department and ask anyone for help. Talk to your teacher, talk to your friends, check out some other videos. There's lots of stuff online to help you study. And do go to the EQAO website itself and have a look at last year's and other years' EQAO, because they're absolutely a good source of help. I hope these videos are useful to you, and I hope you're studying. Okay, see you in school.